Alright, I think I'm recording draft physics video and such. So thought we'd do the two-slit experiment and just go through the questions I'd like answered. So if people are going to keep redundantly presuming that I have no knowledge of the experiment or some other crap, and they're just going to keep linking me to stuff I've seen hundreds of times, that really doesn't work. So if you're going to post a comment, it's going to have to answer some of these questions, or you're not posting a comment on the subject. No, it's got to be a two-way street, people. Anyway, so I'm contending that wave interference is neither theoretically or mathematically a viable explanation for the phenomenon observed in the experiments like the two-slit. So the whole concept of wave interference, applying it to photons or subnuclear interactions, I think was a huge mistake physics made. To imagine the small universes doing anything like that creates all kinds of, I think, logical problems that are just that should give pause to jumping to that conclusion at minimum. So even if you have some, it seems like evidence, you should know that coincidences are going to happen. There's going to be phenomenon you're going to observe that are going to be coincidental. It happens all the time in crime detection, you know, where two people have the same name, or they look the same, or some other thing, and it causes some confusion. That's just part of life, and science should know that, and they should know that, well, just because it looks a little bit like it doesn't mean it is like it. So anyway, so this is the short list of a few problems I see with the theory, and so I will expound on the simplicity of the text. Alright, if the two waves are created in the single slit, so we have two waves pop out of a single slit, single opening, two waves come out, nothing like water, but anyway, why aren't four waves created in the double slit? So it's kind of a simple argument that if the slit breaks waves into two, then why aren't there four waves in the double slit? There's two openings. They should be behaving just like single slits, and they should each create two waves, and so there should be a four-wave solution. Why isn't there? The wave equation does not predict the two patterns superimposed in the double slit pattern. What causes this superposition? I should have put this probably here, but I didn't. Yeah, of course I didn't. So I might go back to this Wikipedia page. I think this image might work. Let's see. Didn't work. Let's see if this will work. Will not let me do that for some dopey reason for which I do not understand. Well, now it did. Alright, so you have these two patterns in the double slit. That is, there's the main pattern, and then there's a pattern behind it of strong dark spots. So there's like two patterns built into the one pattern. And the math doesn't predict that. The wave equation certainly doesn't predict it on its own, and I don't think there's any other math that predicts it besides math that they could contrive to impose some sort of reasoning, in the sense that they can create fake math that says, well, when you go halfway it goes dark, and then when you go halfway again it goes dark again. You know, they can fake something, but there's nothing in their theory, nothing in their Huygens or their mechanisms that would cause the effect. So why is it there? It shouldn't be, logically. I would argue. I think sensibly. So what causes this superposition, the two patterns? In the single slit pattern does not match what is seen in water waves. Why? So it's a simple question. Shouldn't it? I mean, shouldn't the rules be the same? If you're saying the medium is causing this effect, that somehow waves of light, their photons are somehow, you know, it's capable of doing this thing, why isn't it consistent with other water examples or other wave examples? put more precisely. If you're going to use this explicit similarity that exists between the double slit in water and the double slit in light, how come we're not so explicit when there's more slits or when there's less? Alright, the mathematics predicts a gradual gradient from light to dark in the photon slit experiment. Important, photon experiment. Why don't the results match this prediction? So in all the experiments the math says it should be gradual, but it's not in the photon experiment. Unfortunately, I couldn't find any really good images to illustrate that, so maybe I'll just draw it that you know, sometimes the pattern will look depending on what your I would argue depending on how big your laser beam is. The Young experiment actually looked a lot like this. It looked like a lot of little circles. Clearly you can see the pattern in these different ways. And other times you'll see very harsh bars. I mean, very explicitly barish. No gradual from on to off as it's supposed to be. It's supposed to gradually get light, gradually get dark, and gradually get light, and look very smooth, and it doesn't. And so why the two different patterns? Why circles sometimes, rectangles other times, and why in photons is it not very gradient? It is in electrons, but as I pointed out, that's because electrons are big and they're hitting something the same size as them and they're bouncing off the force, which means they're going to do it in a very linear way, in the sense that it's depending on where they hit the other electron, they'll deflect more or less, and that will end up giving you the gradations from light to dark, which you don't see in photons and such. Alright, 5 is the most important one here. This is the one I just recently realized is just glaring right in front of us. Okay, I mean, some of the physics lectures, they've actually done these experiments where they look through a diffraction gradient at a light source and see the different spectra, you know, lines, and they also are seeing an image of the light source is what they're really seeing, and that should be a clue to how this experiment really works. So in the multi-slit experiments diffraction gradient, an image of what went through the slits is clearly projected to the maxima location. So what you get as a bar, or as an image, I mean a location, is a little image of what went through the slit. You can see the image, what went through the slits. How is this projection of an image consistent with the theory of wave interference? So wave interference clearly is implying that you're taking the stuff that was going to one location and pushing it to another location, shoving it. and it clearly implies randomness in the Feynman interpretation, and even in the Huygens interpretation it's implying that from every location there's a random chance of where the photon could go. It doesn't matter whether it went close to a slit or away from a slit. The odds are the same for all the photons, no matter their location. Where clearly if an image is being projected, then photons that are close to the slit always have to go to a certain side of the bar. The image has to be preserved, and that image data wouldn't be preserved if it was wave interference. So what's the explanation for that? How is the projection of an image consistent with the theory of wave interference? Because I don't think it can be made consistent. And one can realize that when you do see the pattern in different forms where little circles, you see little circles, those little circles mean the laser beam is smaller than the diameter of the two slits. Total diameter of the slits is bigger than the laser beam, and therefore that's why you're seeing round images, is because you're able to see the beam. Where if the beam is bigger than the slits, you'll see just the angular bars, because all you'll see is the projection of the surfaces of the rectangles of the slit. When the wave equation is applied to different slit experiments, what property the variables represent is changed. So when they're doing the math for the single slit, they consider how wide is the slit, and then when it's the double slit, they change that variable to how wide is the impediment, and the slit width isn't even in the math. It's an assumed number. So that's how incomplete the math is in the two-slit experiment, that they don't even bother recognizing the need to account for how big the slits are. How is this change recently understood? Another way of looking at it is often people do the needle experiment and call that a double slit pattern when it's not, because that doesn't have the double pattern. It's really a single slit pattern, and they call it a double slit pattern when it's really not. And that's part of the mathematics, the breakdown in the math, is the lack of recognition that this is always just about surfaces. So you have a two-surface experiment, the single slit, and then you have a four-surface experiment, the double slit. And it's just about the surfaces. I just add in the fact that the radar experiment, so I'll say it, the radar experiment signal jamming uses the same mathematics to provide a simpler explanation for the phenomenon. Why is this not compelling evidence against the assumed cause? So using exactly the same mathematics, you would predict the jamming of two radio signals, for example. They need to be, if they are out of phase, you won't be able to tune the energy in. So if you have exactly the same amount of energy from two different signals at the same frequency and they're out of phase, it won't be picked up by the radio receiver. So it's exactly the same mechanism physically, but it's such a simpler explanation for why there's no signal in certain locations. It's because the signal is jamming itself. Alright, in the multiple atom experiments, why, they use an atom of 80 or 100 atoms, a clump, a buckyball of carbon usually. Why is no effort made to detect which slit the atoms went through? So in the atom experiment, you can shoot a little bit of photon at them without deflecting them too much, so you could actually detect what slit the atoms went through. And it appears that they don't even make the effort to do that. I haven't been able to find anybody who's made the effort. Let's also understand that with every time you make the thing you're putting through this mechanism bigger, the pattern gets less and less, gets noisier and noisier. So your signal to noise ratio gets worse and worse. So in the atom experiment, the bars are really faint, barely noticeable. In the electron experiment, it's like 50-50 noise to signal. So it does get a lot worse, indicating that whatever this phenomenon is, it degrades with size, and that would be consistent with the idea that it is electrons causing this phenomenon entirely. And obviously if you hit electrons with bigger and bigger things, they're going to have less and less of an effect on the thing they're getting hit by. Clearly, they can easily affect a photon, and that would argue is why the pattern is most dramatic with photons. Alright, so that's probably enough for the question part, I suppose. Let's see, I don't want to add anything else. No, I think that'll do. So I was reading the Wikipedia page, and it is just so poorly written that maybe we'll do that, just to finish off the commentary on how bad all of this is. So I don't think that we're any other. Well, let me just throw a couple more of these images in here and see if I just don't know why it's not working. It really should work. Come on, load the image. There you go. So you can see in this is an experiment. You can see these bars are very, they're bars. They're not gradually get light and dark. They're bars of light. No indication of a very bright line in the middle and then slowly getting dark and then slowly getting light again and then slowly getting dark. None of that's happening. We already did that one, I think. Oh, that's interesting. Popped it up as an image. Okay, well, just as good. So there's another clear example of the two patterns. So there's clearly two patterns here. The math says there should just be a string of bars here. The math doesn't predict these clumping at all, and in any respect. It doesn't predict how many of these little balls you get here. It doesn't do any of that. So it's completely insufficient in explaining anything like the real experiment. Here's an example of ooh, is that flashing? No. Well, here's a one where you can see the roundness problem I was talking about. Why the roundness? So why straight bars? Why round bars? What's causing that effect? I'm clearly going to argue what's causing that effect is these are just images of what goes through the slits. That's all these are, is images. And if your beam is small enough, you'll see the beam's image will be projected on the locations. And that's why diffraction gradients, when you put a laser beam through those, you get nice perfect circles. And you get nice perfect circles because that's what you put in with the laser beam. It's a perfect circle. It's just an image of the laser beam at the different locations. And wave interference won't do that. I mean, this is all about optics, really, and you know, it's just unfortunate how the sunlight's a little bit much, but you know, what have to do and such. So let's go back to the Wikipedia page. Double-slit experiment Wikipedia. I think that should do. And we'll read some of this slop. Okay, in modern physics, the double-slit experiment is a demonstration that light and matter can display characteristics of both classically defined waves and particles. So it really doesn't. It's been used as an experiment to show wave properties, not particle properties. So even that's written badly. Moreover, it displays the fundamentally probabilistic nature of quantum mechanical phenomena. So again, it doesn't do that fundamental probabilistic thing in the sense that if those are cast images of the laser beam, and in fact it's cast images of anything that goes through. Like I said, if you use your own eye with a diffraction gradient, you can see the projection of images. So clearly not random. The experiment was first performed with light by Thomas Young in 1801. In 1927, Davison and Grimmer demonstrated that electrons show the same behavior. So again, it's not the same exactly, so it is a version of it, but it's not the same behavior, which was later extended to atoms and molecules. So again, more blah blah blah, like it all comes out so perfect, and it doesn't. So it's just, you know, this is sort of just what propaganda looks like. You don't tell the exact truth. You know, you tell the truth you're trying to sell. Wow, that light is amazingly camera unfriendly. Let's see. Not that it really matters, right? Yeah, it doesn't really matter, but see, how can I create a shade? Well, the hell with it. I suppose I could just fold a piece of paper and that should do it. So I'll do it. What the hell? Can't. Should just take a moment to create a proper camera shield that hopefully won't screw up the microphone too much. There, that worked. Mostly. Alright, anyway. Alright, Thomas Young's experiment with light was part of classical physics well before quantum mechanics. Yeah, well, 1801 is a long time ago. And so it's just an extension of the Newton argument. So again, they don't mention Newton here. I don't think anywhere in this whole frickin' paper. And Newton's rings are famous. And it's basically the same exact phenomenon, yet no mention of it. And the concept of wave-particle duality. He believed that demonstrated that the wave theory of light was correct, and his experiment is sometimes referred to as the Young experiment, or Young double-slit is what it's called, but whatever. A clearly unremarkable experiment in light of Newton 150 years earlier having done basically every experiment except the double-slit. He had done the single hair, he had done the small aperture. The phenomenon was well demonstrated by Newton. The experiment belongs to a general class of double path experiments in which wave is split into two separate waves. So again, they just keep saying wave. as if they have some reason to believe they're waves, and well, whatever, and later combine into a single wave. So it's just, what does that mean? Changes in the path length of both waves, again, wave, 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 results in a phase shift. And if that phase shift were true, then you would have to argue, where do the photons that interfere with each other go? And they still have no explanation. Creating an interference pattern, another version of the Mach-Zeelander interferometer, which splits a beam with a mirror. So they just say a mirror splits it with a mirror. Amazing. A 50-50 mirror as stated, but the problem is a 50-50 mirror on a piece of glass that already reflected the light some percentage. So that can't work. Just so bad. In the basic version of the experiment, a coherent light source such as a laser beam illuminates, well, that's not the basic version, but whatever, a plate pierced by two parallel slits, and the light passing through the slits is observed on a screen behind the plate. The wave nature of light, we're just going to keep saying it until you believe it, causes the light waves. They couldn't say light photons or anything like that. No, got to say waves every time, passing through the two slits to interfere, producing bright and dark bands on the screen. So this is all just their assumption that they haven't demonstrated with a fact, and here they are talking about the experiment that's supposed to prove it, and they're talking as if it's a fact. That's like calling the defendant the murderer, in a trial. I mean, it's just kind of a cheat. The murderer, no, you can't do that. The results that would not be expected if light consisted of classical particles. Well, it only wouldn't be expected if you didn't know what particles were on the nuclear level. So yes, if you assume they're bowling balls, then yeah, it's not going to work. But I thought this was about physics, and physics is about atoms and electrons and protons and forces. So just an amazing step. Let's just step right over logic and say that physics is we're not going to acknowledge that atoms aren't bowling alleys. However, the light is always found to be absorbed at the screen at discrete points as an individual particle, not waves. Not waves. Why would you even say it would be a wave or waves? In the first place, because what it's received at is a tiny location receives the energy, and that's not what happens in the wave experiment. So again, you're demonstrating right there with that sentence that, well, maybe this whole theory is in trouble, instead of saying, well, maybe we shouldn't be saying wave all the time because we haven't demonstrated that. Anyway, the interference pattern appears via a varying density of these particle hits on the screen. So again, they call it a wave pattern, yet it's particle hits on the screen. So again, why play this stupid game with the language? Why don't you just tell us what the pattern is and how it's consistent and inconsistent with what waves do? But instead of doing that, they write this gibberish. Furthermore, versions of the experiment that include detectors at the slits, so this doesn't happen. So that's just a reference to the non-existent detecting experiments, find that each detected photon passes through one slit, as would a classical particle, and not through both slits. So they have no citation for that. I guess I'll have to see if these Feynman 65, well, that's not going to work. 2011, well, we'll just have to see what that is. But there's no evidence of these detecting experiments. However, such experiments demonstrate that particles do not form the interference pattern if one detects which slit they pass through. However, such experiments, let's see, in modern physics, double-slit, so there's this same page they're quoting, is a demonstration that light and matter can display characteristics of both classically defined waves and particles. Moreover, the display of fundamentally probabilistic nature. Yeah, so it's the same page. They're quoting their own page in this link of such experiments, where we don't have such experiments. Amazing. Alright, so yeah, so this is a citation to garbage that doesn't exist. It seems that light passes through one slit or the other, in the form of photons if we set up an experiment to detect which slit the photon passes, but passes through both slits in the form of a wave if we perform an interference experiment. So whose experiment did this? So, you know, I don't think that's a real experiment, so we'll have to go there later and find out. But I think that's rubbish. Let's see what this page was. I mean, it'd be nice if they did a detector experiment finally, but I don't think they did. Anything that always conceivable very weak light. Okay, yeah, I don't think it. I think it's just a summation. It's just a book. It's not an experiment or a paper. It's just what some asshole said in a book. Amazing bullshit. Anyway. Alright, so look, they haven't. There's no detector experiment. First, you can't detect a photon, so that's irrelevant. If you hit an electron with photons, you're going to disturb its path, so that's not very practical either. And the only thing you could really do it with is the big atom things, and they haven't tried that as far as I know. Other atomic scale entities, such as electrons, are found to exhibit the same behavior when fired towards a double slit. So again, it's not exactly the same behavior, so it doesn't make the two patterns, like in photons, as far as I know, and the pattern is more smoother, but the smoothness could just be a result of the fact that there's a lot more noise. Additionally, the detection of individual discrete impacts is observed to be inherently probabilistic. Alright, so let's just say they've said this, inherently probabilistic, when the probability is what it seems quite inherent with the diffraction gradient, is that the probability is narrowed to the fact that the image is preserved, therefore photons don't probabilistic. The only thing probabilistic is which location they go to, not their place on that location. Their place is always the same to preserve the image, which is inexplicable using classic mechanics. So again, they say it's inexplicable, they haven't tried to explain it. So this is just more nonsense, where they say there's no reason, there's no possible other alternative explanation, as if they've conceived all the possible alternative explanations, as if they've paid any attention or even looked for them ever. Where I would argue that you can certainly understand that all that happens in this pattern is it creates the simplest pattern you can create, on, off, on, off, on, off. No pattern is simpler in the universe and could be called a pattern, and it's all just about an angle change, which diffraction and refraction on surfaces is notorious for producing, is a change in the angle. So you have good reason to think classical mechanics would have no trouble with this, in terms of just recognizing there's obviously a classical refractor in this experiment, like an electron. The experiment can be done with entities much larger than electrons and photons, although it becomes more difficult as size increases. The largest entities for which the double-slit experiment has been formed were molecules that each comprised of 810 atoms. So clearly you could hit something with 810 atoms with a single photon, you know, a few photons, without disturbing its momentum too much. So they certainly should be able to detect what slit the atoms went through, whose total mass was over 10,000 atomic mass units. Alright, the double-slit experiment and its variations has become a classical thought experiment. Well, it should be a physical experiment, not a thought experiment. And maybe if you do the physical experiment in a few different ways, you'll be able to tease out the truth. Maybe when you notice that having those little round things show up might indicate that those are images of the laser, right? And that might be telling you something about, well, it can't really be wave theory if you're sending images to these different locations. For its clarity in expressing the central puzzles of quantum mechanics. Well, it only does that when you misrecite what the experiment does, which they're really going to do once they get into the next section, because it demonstrates the fundamental limitation of the ability of the observer to predict experimental results. Richard Feynman. So they're quoting, I don't know where Feynman said that. Oh, okay, he says this part, they said that part. I mean, that's a terrible sentence, because it demonstrates the fundamental limitations of the ability of the observer to predict experimental results. No, we can predict the results very easily. So that's just nonsense. What we're trying to do is understand the results. Called it a phenomenon which is impossible, then they cut out that part, to explain in any classical way. So again, because Richard Feynman couldn't figure it out, nobody could ever figure it out. Oh, and that's the truth. We can declare it, no, there can't be any other possible explanation because Richard Feynman didn't think of it. I mean, the logic here is just so stupid. And which has in it the heart of quantum mechanics. So again, if this is what its heart is made out of, this incredibly weak evidence, then it's maybe a heart that should be pulled the frig out. In reality, it contains the only mystery of quantum mechanics. So this is all Feynman kind of mush. And so he's basically saying that, yeah, you solve this, then you've solved it. So again, I could argue that it's been solved by the fact that this theory doesn't, the evidence doesn't fit what they're saying. It isn't as they say it is in the first place, the evidence. And the evidence demonstrates that when you really analyze it, that there probably is some other explanation, because these are images. These are images going to specific locations. They're all just being, they're either going 3 degrees or 6 degrees or 9 degrees or 12 degrees. It's all very, very predictable. Alright, if light consists of strictly of ordinary classical particles, there's no such thing as a classical particle. Come on, be at least a little bit fair, that there's the difference between kinetic particles and elastic particles. You can at least concede that classical particles are not one thing. Gee, there's hard things and soft things. You can figure that much out, right? You're supposed to be physicists. Anyway, and these particles were fired in a straight line through a slit that allowed to strike a screen on the other side. We would expect to see a pattern corresponding to the size and shape of the slit. Yeah, and instead of one pattern, you're seeing a whole bunch of them. However, when this single slit experiment is actually performed, the pattern on the screen is a diffraction pattern. So here they call it a diffraction pattern, when clearly it's the same pattern. You just open the slit a little bit and these two images look the same, except for these breaks, right? The double slit creates these silly breaks. But if you open up the slit, this pattern will have just the same number of bars, be just as barry. So again, it's just more huge distortion, in which the light is spread out. So it's not just spread out, it's spread out in on-off pattern. So again, more just distortion of the truth. The smaller slit, the greater the angle of spread. Yes, and that's going to be true for the double slit also, but you don't have the width of the slits in the math, so you can't make the slits smaller, because mathematically you don't have any variable for that. The top portion of the image shows the central portion of the pattern formed when the red laser illuminates a slit. And if one looks carefully, the two faint side bands, more bands can be seen with more highly refined apparatus. Yeah, by highly refined apparatus, opening the slit a little bit. Open the slit a little bit, looks just like this image. So again, just a huge distortion. They're always using this huge distortion, pretending the single slit doesn't create a pattern, the double slit does. No, single slit, same pattern, just open it up a little wider. Pretend it's diffraction, you know. More bands can be okay. Diffraction explains the pattern as being the result of the interference of light waves from the slits. And interfering how? In water waves, they don't interfere with a single slit. They just, you know, nice round waves. If I poke my finger in a bucket of water, the waves just go out round, no interference. Not at all like water waves, but instead of saying that, they do this distortion of reality. If one illuminates, let's see what they said here. Same double slit assembly. In the top image, one slit is closed. In the single slit image, a diffraction pattern forms due to the non-zero width of the slit. The non-zero width. Hilarious. See, they can't give it a width because they don't have room for that in the math, because they used up their variable to do the width of the impediment. A diffraction pattern is also seen in a double slit image, but at twice the intensity and with the addition of many smaller interference fringes. So again, you'll get all the smaller interference fringes if you just make the single slit as big as the total opening of the double slit. So if you make the two experiments have the same amount of light go through them, then you'll get patterns that are more similar, obviously. Alright, if one illuminates two parallel slits, the light from one slit again interferes. Here the interference is more pronounced pattern with a series of alternating light and dark bands. So again, it's not more pronounced pattern. It's just, you know, they're just, I mean, what is that besides a lie? If you do the single slit experiment right, you get just as clear bar pattern as you do in the double slit. The width of the bands is a property of the frequency of the illuminating light. Well, that's not the only thing. See the bottom photograph to the right. Well, whatever. When Thomas Young first demonstrated this phenomenon, it was indicated that light consists of waves. Again, Thomas Young's experiment was done with white light, and the circles were the pattern. As the distribution of brightness can be explained by the alternately additive and subtractive interference of wave fronts. So again, just more arguments about wave fronts that have nothing to, I don't even know how that, yeah, that wavefront reference isn't even related. Young's experiment, performed in the early 1800s, keep saying it over and over again, played a vital role, here we go, in the acceptance of wave theory of light. And yeah, this is all just really bad. It goes back to Huygens and this theory that because light moves slower in a substance, that somehow the slowness is what's bending the light. You know, because somehow the light is all connected and it all goes where, if one photon goes slower down, then all the photons go slower down or something. But if it were true, then the slowness of a substance, it would matter how thick it was. You know, it wouldn't stay 40%, because the slowness, like halfway through the substance, you'd have 40% less speed of the light, and so now it's already reduced its speed by 40% just by going halfway through. And now you have to cut that speed into 40% and then that speed into 40%. There's no indication that the light actually slows down more and more as it progresses through. Their theory is dependent on the light being bent as it goes through the whole substance. And that's not how it's happening. It's happening on the surface. Anyway. Alright, so that's probably we'll give up here. Well, anyway, so I'm here. First demonstrated this phenomenon. It indicated that light consists of waves, as the distribution of brightness can be explained by the alternating additive and subtractive interference of wavefronts. Young's experiment. Okay, we already did that. It played a vital role. Vanishing the corpuscular theory of light proposed by Isaac Newton. So again, you know, it's not like there's only 3 people in the universe. I mean, again, Newton had so little information. So I'm clear that I'm certain there could have been more brilliant arguments. And clearly they don't talk about Fadio or anybody else who had theories of particles, particle theories, which has been the accepted model of light propagation in the 17th and 18th century. So that's just more nonsense. Clearly, Huygens and wave theory was the dominant theory, and it's just, they're just talking crap. Anyway, however, the later discovery of the photoelectric effect demonstrated that under different circumstances, light can behave as if it is composed of discrete particles. Well, even in this single slit experiment, it's behaving as if it's discrete particles, in the sense that that's how it's landing on the screen, obviously. These seemingly contradictory discoveries made it necessary to go beyond classical physics and take the quantum nature of light into account. So again, more just talk about, we need some special invisible nonsense. We need to make up fake crap to explain this. And no, that wasn't the right, that was taking a wrong turn. Feynman was fond of saying that the quantum mechanics can be gleaned from carefully thinking through the implications of this single experiment. And again, Feynman did not think photons were waves. So here they are quoting Feynman in a paper arguing that somehow the wave crap is the truth. He also proposed as a thought experiment that if the detectors were placed before each slit, the interference pattern would disappear. So more before each slit. So again, I don't know how, if the detectors are before the slit, how they could prevent the photon from getting through the slit. So that doesn't even make sense. But anyway, the Engert-Greenberg duality relation, I'm sure that's a pile of crap, relates the visibility of interference versions with the definiteness or distinguishability of the photon's path, whatever that is. Yeah, that sort of sounds like crap. Provides a detailed treatment of the mathematics of double-slit interference in the context of quantum mechanics. Well, we'll go look that up, but I'm sure it's not. I'm sure it's gobbledygook. A low-intensity double-slit experiment was first performed by I.G. Taylor in 1909 by reducing the level of incident light until photon emission absorption events were mostly non-overlapping, meaning there was only one little dot of light per second. A double-slit experiment was not performed with anything other than light until 1961, and curiously, even these single photon experiments weren't duplicated by anybody ever again, it seems. When Claude Johnson, the University of something or other, performed it with electron beams. I don't know, there's supposed to be one beam. So again, that doesn't sound right. Yeah. In 1974, the Italian physicist Pierre whatever blah 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 and a bunch of other foreigners repeated the experiment using single electrons and biprism instead of slits. So let's just, change all of the geometry and the mechanics and then pretend it's the same experiment, showing that each electron interfered with itself as predicted by quantum theory. So just more crap. In 2002, the single electron version of the experiment was voted the most beautiful experiment by readers of Physics World. So again, the diluted, voting for their pope. Oh, he's the prettiest pope ever. In 2012, another guy and co-workers eventually performed the double-slit experiment with electrons and real slits. Oh, so they finally did it with real slits in 2012. They did it actually as the experiment should be performed. Following the original scheme proposed by Feynman, they sent single electrons into a nanofibrated, whatever that is, nanofabricated slits. So it is curious that something bigger, like electrons, they have to do the experiment with smaller slits. I mean, electrons are bigger than photons. Why do you need smaller slits? About 100 nanometers wide. And by collecting and transmitting electrons with a single electron detector, they could show the buildup of the double-slit interference pattern. So again, it's engineered experiments to collect the information they want, and that's all there is. So you got variations of the experiment. I think we won't bother with this one for now. Which way experiments, delayed choice experiments, just more versions. Instead of doing the original experiment and figuring out why what happens, they just keep coming up with more complex ways to do it, and ways in which more chicanery is possible. So anyway, back to the questions, I suppose, and call it a video. So there's probably other problems that I've detailed before. I mean, reasons to doubt. That's all I'm proposing, is reasons to doubt that they have sufficient evidence to draw conclusions and to keep using this concept of wave to describe a photon. Again, this assumption, because none of them have articulated any other mechanism, that no other mechanism could be understood to be a cause. And it's clearly because they just don't account for the matter at all. They're just pretending matter is solid. That atoms don't really exist, and that atoms don't have a bunch of empty space in them, that atoms aren't made of protons and electrons, They're just assuming that slits are solid things and they don't do anything except prevent photons from getting through. That there's no, there couldn't possibly be any kind of field created by the surfaces. No, that's not possible. So anyway, I think it's pretty poor performance for science. As science, this is junk science, and it, you know, just gives physics a bad name. This jumping to conclusions, very bad form. So we'll call it a video. Till the next time and such.